Pressure gradient force is the force that pushes air from high pressure to low pressure. Just like a ball rolling down from the top of a slope, the greater the difference in pressure, the stronger the gradient force. We can treat air in the atmosphere as static air columns. Warmer air in general has a taller air column due to thermal expansion, while cooler air has a shorter one because of thermal contraction. At certain height, the isobaric surface in the warm air column is higher than that of the cooler one due to the thermal expansion. Air particles, just like the ball, would roll from higher to lower pressure levels to balance the pressure. And this driving force is the pressure gradient force. As mentioned before, Coriolis force is a large-scale, apparent force acting on objects moving in a rotating system, and it actually arises from the conservation of angular momentum. It will deflect moving objects rightwards from its moving direction in the northern hemisphere and leftwards for the southern hemisphere. The higher the latitude, the stronger the Coriolis force, and it can even deflect the wind direction instilled by pressure gradient force. Eventually, the wind direction will become steady when pressure gradient force and Coriolis force balance one another, and we call this the geostropic balance. While Coriolis force increases with latitude, pressure gradient force can be strengthened with a stronger temperature difference. On a planetary scale, the pole is very cold compared to the warm equator on Earth. These strong temperature gradients can lead to strong pressure gradient force. At high latitudes, there exists instance that the strong Coriolis force balance with the strong pressure gradient force, and this results in a belt of strong westerlies up high in the sky in those latitudes. And this is called the jet stream. In fact, jet stream is not just a zone of perfect easterly, nor does it have perfect temperature and density gradients in our weather in a tank setup. Baroclinic eddies are formed as Earth has to transport heat from the equator poleward, and these eddies would create instabilities towards the jet stream, that the stream may not be straight in shape, or not even a complete belt occasionally. Even the stream isn't perfect, it is still involved in many weather systems in mid-latitudes, like extratropical cyclones and the Pineapple Express in the US. And it is also the reason why you travel faster when flying from Hong Kong to the US compared to the return journey.